Okay, so in this video, I want to talk a little about business investment decisions. Um, you know, in due time, many of you here will perhaps become business managers. You probably want to get into maybe manufacturing, uh, maybe, dabbling in investments as well, right? Whether you invest yourself or, you want to have other people invest in maybe a business idea that you have or some kind of scheme that you have, right? And when it comes to, all these areas, whether we're managing a business or we're doing any kind of investment, it's very important that you know how to make business investment decisions, right? Because that will actually determine whether your business, you're going to talk about profits or whether you can be able to sustain the business, right? If you make the right choices, right? Well, you never know, you can have a lot of profits. While if you make a poor decision, then you can suffer a lot of losses and so on. That can mean people might not have confidence in you. They might not want to invest in you later on and so on. And when it comes to these things, it's not about luck and all of that. Very often, we want to be able to make informed decisions. And that's why we want to talk a little about, the mathematics behind it. As I mentioned repeatedly, right, because you all are newbies, you're now getting into the world of business. There are lots of, or there's a lot of mathematics you need to know in order for you to, be able to analyze investment opportunities and to analyze a business and how it's doing and so, right? However, we're just going to consider um, a few things here, a few approaches that we can use, right? And um, well, a little bit of mathematics behind it and how we can come to a decision as to whether, this idea here is investable or not, whether we're going to make a profit or loss, right? And remember, none of this is 100% sure, right? Because there's always that probability that what you factor in the calculation, um, those parameters, those factors change, right? I don't want to get into all those uncertainties, right? Just to focus on, some simple approaches that we can analyze a business idea or venture, right? And to see whether, it's going to make money or not, right? So one of the things you want to look at is when it comes to investment decisions is the time value of money, right? The reason for that is that um, money changes value over time. What we are observing in the present economy is that money keeps getting, it's devaluing because of what we call inflation and changing interest rate, right? So keep that in mind. So that's one of the things we're going to factor in our calculations, right? To show well, all right, what will happen to our money as time go by, right? And how that can affect our decisions and so. Now, um, we're going to be using some different approaches. Two approaches we're going to look at is one is called the discounted cash flow, right? Discounted cash flow. I should write that. Um, okay, I mean, yeah. So this next slide has it. Discounted cash flow, right? The DCF approach, right? And then there's something called the NPV or the net present value, right? Net present value approach. So that's Undertake to you. When you're making these decisions, these are two approaches that you can use. That one is net present value, right? So come to this yourself. NEV, right? So these two approaches we're going to use, right? So, um, and in both of these approaches, you're going to hear some terms, right? You're going to hear about cash flow. We're going to talk a lot about cash flow. You start seeing it on the screen. We're going to talk about cash inflow, right? And that's money you expect to come in, right? You're expected to receive, right? So whether you're selling goods, whether you made some money, you invested some money, you're going to get some interest on it and so on, right? That sort of thing. And then you hear about cash outflows, right? And that's money you have to spend, right? As I say in business, you have to spend money to make money, right? So you have certain costs, you have to maybe have some infrastructure, raw materials to make whatever you're making. You have to pay employees, maybe you took a loan, and so on, so on, so on, right? So those are outflows, and you're going to hear those terms a lot when it comes to these two approaches we're going to use to analyze a business venture and decide whether, well, are we going to pursue it or not, right? So let's start. Let me erase all of this. So I'll start with, give me 1 second. We'll start with the discounted cash flow approach to making investment decisions. So this is a nice formula, and this formula, what the formula is all about, right, is that it estimates really an investment's value by discounting each of its expected future cash flow back to the present value. And if you watch the formula, you see a lot is mentioned about PVs, right? PVs, present value. So you wanna actually analyze this venture, right? So whatever cash flows are going to be there, you want to discount it, right? What will be its value now, right now, right? And if that value is more than whatever investment you have to put into the business, well, it means you're going to make a profit, right? So keep that in mind, right? And we're going to look at some examples. So let's take an example of what we're talking about. So here, company is considering investing $30,000 in a project, right? So they said the expected returns from this investment, they project that, well, okay, you're going to get 8,000 in 1 year, 13,000 in year 2, and 16,000 in year 3, right? So the company's required rate of return for investment is 8%, right? Calculate the discounted cash flow and determine whether this is a worthwhile investment. Right? So let's see. So all the cash flows, we're going to put them down, all the information required, interest rate, the same rate to be, they give you about 8%. We're looking at, yes, annual returns, right? So the compounding period, well, it's 1, right? 1. So the return or return rate is going to be 0.0. 8% is 0.0, right? So this is what you want to put into this, you're thinking of putting in. This is what you'll get the first year, second year, third year, right? So got all these here, cash flow time, 1 year, 2 year, 3 years, right? But so all the basic information is there. So what we do now is we calculate the present value of all these cash flows, right? So remember they said that, okay, uh, year one, right? At the end of 1 year, you're gonna actually get 8,000. So what you're doing, you're discounting, you're using really what we call the, I remember when we did uh, compound interest. We can rearrange the formula to get or to put the future value here instead of the PV, right? So you're taking the future value and you're kind of calculating the present value, right? I don't know if you remember that formula. So that's what we're using here. The formula of compound interest where the future value is inside here. And when what the output of it is really the present value, right? And that's what you're doing here. So here it is, $8,000 in present value. I'm going to use the formula, is going to be this. $13,000 in present value is going to be this, right? And $16,000 in present value is going to be this. And when we add up the present value of all these cash flows that are going to come in the first year, the second year, the third year, right? We get a present value of $31,000. Right? And $31,254.14, right? I said 31,000 and change. You know, is the way I speak. Yeah? So what you're seeing here, these people were willing to expend 30,000, right? So notice the discounted value from all those cash flows that they will get in the future. They're projecting this, right? Adds up to 31,000 shillings. So because that amount is greater than what they're actually putting in other words, they're saying that to get that kind of return, you're supposed to put in a little more, right? So what they're figuring out here is that putting in $30,000 is like it's good, it's a good investment. They're supposed to be putting in more than 31,000, but here it is, we putting in 30,000 and you'll get out those cash flows in year one, year two, year three. You see? So it's not a bad investment. Of course, I know you were saying $1,000, but in reality, it has to be much bigger than that, right? You wouldn't. I mean, in this problem, the person says it's a good investment, but don't forget, we're using very small numbers, 8,000, 14,000. Even if this was US dollars again, it might make sense, but in reality, the numbers will be much bigger. So if you are discounted present value is much more than you are willing to invest or you have to invest, well then that is telling you that, you know what, this is a good investment, right? This is a good investment. Let me go ahead and spend the 30,000 because the discounted value of those returns is actually greater than 30,000. See? So this is a good investment, right? Good as in the context of this question, but in reality, you want to make sure that your discounted value is much, much, much more than what you're willing to invest. Like, let's just use some money in Guyana terms. Let's use some Guyana values. Let's say you want to put in $1 million in an investment, right? Don't, if you are going to do some, let's say the present value of discounted cash flows, right? You want to make sure there's a good margin between this and that present value, right? The cash flow from all the other cash flows like from year 1, 2, 3. I don't know the age of the or how many years the business is going to go on for. You want it to be much more than $1 million, right? So keep that in mind, right? In this problem, it was just 1,000, and this is a good thing. For us in Ghana, nobody would kind of go into a business like that, right? So Ghana money is so low, $1,000 is nothing we're going to see. Yeah. So that's the approach there when you use the discounted cash flow, right? You look at all you're going to get in the different years and kind of discount it at the beginning. How much would you have had to invest to get that? Right? And in this problem, you're telling me you should have invested at 31,000. So the fact that you are only investing 30,000 means this isn't a bad deal, right? 31,000 change would have given you those kinds of um, revenue in the future. But you are only putting in 30,000, so that's good. It's a good thing, right? Let's take another example. This one they're trying to compare, right? Yeah, they're comparing two businesses, right? They're comparing two businesses, business ideas, right? So it says the CEO of an ice cream company is choosing between two investment options, Project A and Project B. Um, Both of them require the same initial investment. They say, okay, Project A is expected to yield returns of 45,000 in 1 year and another 45,000 in 2 years, right? Um, in contrast, Project B is anticipated to bring in 10,000 in 1 year and 80,000 in 2 years, right? So with the company's required rate of return set at 12%, which project should the CEO choose based on the financial viability and the expected returns of each option, right? So we're comparing two projects. You have in mind Project A, Project B. Both of them require the same initial investment. So those two things are equal. So what we're going to do now, we're going to do what we call the discounted cash flow. But take the monies that you're going to get in year 1, year 2, right? See what's going on, right? See when we discount it, what happens, right? So let's, okay. So I think that this is Project A, Project A. So yeah, so I was trying to figure out why they use the annuity formula. So the simple reason being is that both years the return is going to be the same, right? So that's the kind of annuity. They are getting $45,000 every year for those 2 years. So because they're the same, no need to use two sets of formulas, right? From the compound interest formula that we rearrange, right? So we're using the annuity formula. The reason is, as you see at the top here. Oh, yeah. The reason you see at the top here is that they're going to get $45,000, same amount of money both years. So we're going to use the annuity formula, right, to get the present value. And for Project A, the present value is going to turn out to be $76,052.30. Right? So let's analyze Project B now. So Project B, notice because the cash flow in the different years is a different value, we can't use the annuity formula, right? And you want to know, you might want to know, why are we moving, one time we're using the compound interest formula that is rearranged, and next time annuity, right? They use the annuity formula in the previous slide because it's one calculation. And the reason why you could have used it is because the 45,000 return was the same for both years, 45,000, 45,000. But notice here in Project B, the future value, right? Or the returns is going to be one time 10,000, the other time 80,000. So we can't use the annuity formula. So we have to go back to that compound interest formula that we rearrange, right? To get present value from. And that's what you see here. And we apply the formula twice, right? One time for the 10,000 and the other time for the 80,000. And what you see here is that, what was the other one? The other one was 76,000, right? Yes, I think so. 76,000. And therefore, because 76,000, this one is 72,000. So the simple conclusion then, right, is that since project A has a higher discounted cash flow value than project B, well then project A is definitely the investment of choice, right? Should be the one we go after because it gives us a greater um, present value then, right? Present value of all cash flow. The project B is only going to is only the discounted value is just 72,000 change. The other one was 76,000. Right? So yeah. So that's that method we call the discounted cash flow. Right? So let's take another method now. Right? We're going to look at another method that we can use. And this method, we're going to talk about something called net present value. Right? And we're going to look at the whole concept hinges on, well, how does inflow compare to cash inflows compared to cash outflows? And that I think that's common sense for all of us, right? If money is flowing out of the business more than it's coming in, well, you know, it's a bad idea, right? So notice if they say if NPV is greater than zero, well then yes, maybe it's a worthwhile project. NPV equals zero, we're not certain what to do, right? And one might very well want to stay away from that too. And then if NPV, your net present value, is less than zero, definitely you're going to make a loss, right? So your inflow is going to be less than your outflow. You're going to get negative, right? And it might not be the best of ideas. So keep that in mind about this approach, right? When it comes to making a decision about whether we should invest in something or not, right? I'm going to look at a simple example. Look at that. Yeah, look at this one here, right? So here we have a company, they're evaluating a project, right? And the project requires $30,000 investment. Right now, they need, right, today. The expected return from this investment are projected to be 8,000 in 1 year, 13,000 in 2, 16,000 in 3. I think we did the same problem, I think, using the discounted cash flow approach, right? In the last thing. So we're doing this now, but we're using the net present value, right? So let's see. So we have all the information here, just like the last time. Let's evaluate, right? So we have to spend $30,000 for the business, but what is it going to come in, right? Good. Now you can't use the 8,000, the 13,000, the 16,000 because that's a couple years from now, right? That's a few years from now. You'll get all of that money. You have to discount, you have to kind of backdate that money, right? And we're going to use the present value formulas from where we did compound interest, right? And we're going to kind of discount, those money that we're going to get, the 8,000, the 13,000, the 16,000 present day value. And we're gonna get those sums we have there, 7,407 and change, 11,145 dollars and change, $12,701 and change. You add them up. And what we see again, all the cash inflows at today's value is 31,000. So the fact that that is actually greater than the outflow, right? I think the next slide here. The inflow is greater than the outflow. Well, you can make a decision that yeah, this might be something we want to get into, right? Again, I mean, this is not the guy, especially in Guyana, right? You are not going to, you know, for this small net present value difference, it might not be the quantity that you're looking for, right? You look for a larger value, but let's take it in the context of the business, and yeah, we're going to accept this decision that you made, right? Second one, so here we're looking at the net present value along with, you can get what we call an annuity cash inflow and residual. Residual is like, you know, at the end of the business, you have something left back that you can probably sell and get some money from. That's the whole idea, right? So let's take this one. So company, they want to invest in machinery to expand its manufacturing plant. It would need to invest $40,000 today and $20,000 in 1 year. The machinery is expected to generate a net return of $6,295 at the end of every year for 11 years, right? At the end of the 11 years, the machinery is expected to have a salvage. You know, like, it's got old now, ready for, you know, can't do not much, but we got to sell it. That's what they call a residual value of 10,200, right? And you can consider that as a cash inflow. So the company's required rate of return for investment is 5.4%. They want you to calculate the NPV of the investment, determine whether the purchase of the machinery is a financially sound decision if we were to use this approach, this NPV approach, right? So the information is given there. Let's see. So, right, so cash outflows. You have to spend 40,000 right away. So you don't have to do anything with that calculation. The present value or the present outflow is 40,000. In 1 year's time, though, you'll have to spend 20,000, right? In present value, that might be a little less, right? So that's what you're seeing here. In 1 year's time, 20,000, the value of it now might be a little bit less, right? So all the outflows will add up to $58,975. Good. So that's our outflow. What about our inflow? Let's do some calculations. So they put on all the information here. You're going to get $6,295 every year from the business for 11 years, right? So yeah, my mistake here. You're going to get $6,295. Inflows we're dealing with, not outflows. We just talked about outflows, right? And at the end of the business, you are going to sell the machinery for $10,200. Good. So let's see if we can calculate what all of this means in present day values. Let's see. So, right? Remember, because you are going to get an inflow of, what is it, $6,295 every year for 11 years. We don't use the compound, the rearranged compound interest formula. We're going to use the annuity formula. Right? Keep that in mind. So that's why you're seeing that PMT in that formula there, right? So you use that, that will give you the present value. Also the cost of the machine that you're going to sell, right? In 11 years' time, it's going to sell for 10,200, right? But in present day, it's going to be a lot less, as you see here, right? It's just about 5,000 when you put it in that second formula, right? So what happens when you calculate all the inflows? You get $56,927.01. So when you apply the NPV formula now, you see we end up with $2,048.32 negative. Notice, right? Your outflow is actually greater than your inflow. And that means, that you're spending more than you're actually getting back, right? And therefore, you say, look, you know what? This is definitely not a good idea, right? This is definitely not a good idea or a good business idea to get into, right? Because you're going to be spending more than you will get back when we consider it in present day money, right? So in this one, I'm not going to do this one. Maybe in the tutorial, I'll consider this one. Here is two business ideas, right? Right. Company wants to use two different strategies in their, so we want to compare using the same NPV approach. We're going to do this one in the tutorials, right? So, but it's not difficult. You also have to take strategy A, right? Work out the net present value, right? And you take strategy B, you do the same, and then you look at which one is better, right? Which one is better, and you make a decision. You can work on it. I think I gave you the answer in the notes, right? So you can look at it, and during the tutorial, we're going to discuss it, right? So so this is a very good, start in understanding how people make business decisions, right? Um, keep in mind it's oversimplified. There's so many other factors, right, that we haven't considered here because you have to look at what you call nominal interest and inflation rate and effective interest, and so very complex considerations, right? Nevertheless, this is a nice introduction, right? And I know you laugh at when we were doing the two approaches, right? In net present value and the discounted cash flow. And so on, you were seeing that, well, the differences between what you want to invest and how much the discounted cash flow and so or the net present value is very small. So if it's this money, I'm going to invest. But remember, in reality, you look for larger values. The bigger that gap between what you want to invest and what the discounted value is, the better, right? The bigger. And there's where, again, you might want to think that, well, okay, what size of difference am I looking for that would make sense, that would justify my investing all this money, right? We haven't done that, but maybe that's for a more advanced course, You understand? And don't forget, maybe you do a course in market research. And so as you want to get into something that in the future nobody wants to buy it and all of that. So all those courses, when they add up to your knowledge, you'll be in a better position to make sound business investment decisions, right? This is just a start, right? And a little bit of mathematics. And it also see you can also see how your compound interest formula, your annuity formula is still being used, right? So that's why I chose it, because I'm not telling you to learn a whole set of new formulas. They're old formulas that keep working for you, right? Good. So I'll stop there. Next, we're gonna look at break-even analysis. The next video is gonna be about that, right?